Hello everyone, welcome to Lemon Code 21. In this opportunity, we will learn how to create a robust and efficient logging system using FastAPI and integrate it with Elasticsearch, Kibana, and Filebeat. Logging is a crucial component in software development, as it helps us track events and issues within our applications. In this video, we will explain the steps in detail. Let's begin by outlining our learning agenda. First, we will start by getting acquainted with FastAPI, a lightning-fast Python framework for building RESTful APIs. Configuring logging. We'll learn how to configure logging in FastAPI to collect relevant data. Elasticsearch and Kibana. We'll explain what Elasticsearch and Kibana are and how we can use them to store and analyze logging data. Configuring Filebeat. We'll show how to configure Filebeat to collect logging data from FastAPI and send it to Elasticsearch. Practical example. Finally, we'll take a look at a practical example of how this logging system works in a real FastAPI project. Before we start, we first create a virtual environment and add the UVicorn and FastAPI dependencies. First, create main Python file. The code begins by importing two essential modules, UVicorn and FastAPI. UVicorn is a web server that allows you to run SGI applications, and FastAPI is a modern Python web framework for building web APIs quickly and easily. The initApp function is created to initialize and configure the FastAPI application. Within this function, the following tasks are performed. An instance of FastAPI is created and assigned to the variable apps. Metadata for the application is provided, including the title, description, and version. Two event handlers, startup and shutdown, are defined within the FastAPI application. These event handlers are typically used to execute code when the application starts up and shuts down. In the provided code, the event handlers are empty, so no specific actions are taken during startup or shutdown. We make a simple router welcome. The function returns the configured FastAPI application. The initApp function is called, and the resulting FastAPI application is assigned to the variable app. Next, let's input UVicorn run into main program. Next, we create a logging setup function to format the logging that we will create. Define a class called LoggerSetup. This class will encapsulate the configuration and setup of the logging system. In the constructor init, initialize the LoggerSetup class. Begin by importing the necessary Python modules, logging and logging handlers. These modules are used to configure and manage logging within your application. Here, you create an instance of the root logger using logging getLogger and call the setup logging method. In the Setup Logging method, you configure the logging system. The steps involved in this process are: define a log format, which includes the timestamp, logger name, log level, and log message. Set the logging level to info using logging, basic config. This ensures that log messages with a severity level of info or higher will be processed. Create a formatter using the defined log format. Configure a console handler, console, to send log messages to the console. Standard output. Attach the formatter to this handler to format the log messages. Configure a timed rotating file handler, file, to log messages to a file. This handler rotates log files daily when midnight and keeps up to 5 backup log files. Attach the same formatter to this handler to format log entries consistently. Add both the console and file handlers to the root logger. This allows log messages to be simultaneously displayed on the console and written to log files. After that, we add the logging setup function to the main file. Also add login to startup and shutdown events. Let's create a simple controller to do a test logger on AP. The code starts by importing the necessary modules. In this case, it imports API rotor and path from the FastAPI package, and it also imports the logging module. A logger instance named logger is created for the current module, name. This logger will be used to log messages specific to this module. An instance of a API router is created and assigned to the variable router. This router will be used to define routes and handlers for specific API endpoints. The router is configured with a base path of /home using the prefix parameter. This means that all routes defined within this router will have paths starting with /home. Tags are also specified for this router, categorizing it under the home tag. In the route handler, a log message is created using the logger info method. It logs welcome lemon code 21 to the logger. The handler returns a string response, welcome lemon code 21. We give the second router the name test by adding the logger info welcome page test. Now, let's try running it. If we see that there are some errors because the log files are not correct, we can just change them. Let's try. Okay, everything is running and the log is displayed in our terminal. If you look in the logs folder, all the logs have been saved in the file. Then we connect to Elasticsearch. We create a Docker file for FastAPI. We create a Python 3.9 image. We copy the request text, then we create a sarc file as workdir and run the unicorn command. Next, we add the Filebeat folder. Add the Filebeat config file and the Docker file. Then you can just copy it from the init repository. The most important thing to remember is that the target file for the log is stored in the path. Okay, next we create Docker compos from Elasticsearch, Kibana, Filebeat and FastAPI. Here we run it with Docker Compose up. If we see that there are still errors regarding the placement of the log file, we need to change the file path a little. Let's try running it again. Okay, we can see that it's running. If we look at Docker Desktop, all the containers are running. Let's try the test now. After we test all the routers, try entering the Kibana application and open Index Management. Add the index to the Kibana index pattern. If we have opened Analytics and looked at Discover, you can see here that we can monitor all the logs in Kibana. Let's try one more time to test the router. We will refresh the dashboard if you see that the new data log has appeared.